All right, folks. Happy Monday. How's everyone doing? Exhausted. Oh no. Why is everyone so tired this morning? Aw. How many of you folks work? Anybody work on weekends or during the week? Yeah, you work a lot. Oh man. All right. Well, my sleepy folks, let's go ahead and get started with announcements. So I'm going to go ahead and share my screen so we can take a look at the announcements on Canvas for this week. All right. So believe it or not, we are in week 5. All right. We are in week 5, which means we have officially finished half of this class. And we have half more of this class to go. And then we have a whole nother class this semester. Yay. So here are a few announcements for this week. All right. So we have exam 2. That's going to be tomorrow. So exam 2 is going to cover chapter 3. It's going to cover 3.1 through 3.8. Like the last exam, you want to make sure you prepare your statement of integrity and reference sheet in advance, okay? That'll just save you time when you get started, so you can upload those right away. You can even take the photos or the JPEG files, not JPEG, the PDF files, so you can have those ready to go and upload those right away. It's especially important for those of you who maybe lost points on the first exam for not having a reference sheet or not having a statement of integrity. So just make sure you have those all complete, and at the end of the semester, or end of the course, I'll give you those points back, okay? So exam 2 is gonna open at 9:30 tomorrow morning, and we'll close at 9:30 on Wednesday morning. Now this time you're going to have 2.5 hours. So once you open the exam, your time starts. So make sure you have a good block of time in which you have as reliable internet as possible, and that you have time to sit and do that undisturbed, okay? Yeah, the statement of integrity is going to be the same as last time. So whatever you have for last time, you can go ahead and copy it again for this time if you need, okay? Are there any other questions about exam 1 before we talk about week 5? Okay. I know some of you have already been working on your reference sheets as you go. If you haven't started your reference sheet, I think today is a great day to do that, just so you can start to think about what's important. And I would definitely use the topic list that I posted for exam 2 to kind of use that and guide your reference sheet, okay? All right, so this week we're going to cover 3.7 today. So I'd ask you to complete 3.7 part 1 on your own time. We are going to do a little warm up that reviews that today, and then we're going to spend most of the other time on the other part of 3.7, okay? On Wednesday, we're going to start unit 3, and that is going to cover conic section. The homework 4 was due last night, so I got those. Quiz 9 is due at Wednesday at 9:30 a.m. Quiz 10 is due at Friday morning at 9:30 a.m. There is classwork 9 that's already been posted. It's a survey link, right, if you click on classwork 9. I know a few of you have already completed that, so thank you for that. If you haven't completed it yet, please do so by 5 p.m. today. Classwork 10, we will just do in class on Wednesday, okay? And there is a homework 5 that is due this Sunday as well. I know we're sort of getting into the swing of all of these things being due all of the time. So I hope you found a way to kind of manage your schedule and remember the deadlines. And then just a reminder of the support sessions. So we've got Val's Monday, Wednesday sessions, and we have my Monday and Wednesday morning office hours. Okay. There are also tutors in the STEM Center that you can reach out to. If you want more support. I also know that Val has hours outside of the dedicated STEM core time. So that could also be something if you felt like you wanted a little bit more time today. I think she actually works at the STEM Center until maybe 7 p.m. or something. So I would ask her if you feel like you want a little bit more support. She might be around. She might be working with other students in different classes as well, but it doesn't mean that she can't work with you as well. Okay. I did see one question in the chat about rewriting the statement of integrity. Yeah, you can reuse the same one if you want to. That's fine. Just make sure that you did it correctly the first time. Okay. All right. Any other questions on the announcement? All right. So I'm going to stop sharing my screen here. And I'm going to go ahead and share the warm up on the screen. Okay. So it is just handwritten, but hopefully we can take a look at that. All right. So I asked you to take a look at the first part of 3.7 on your own time. And so today's warm up is 2 questions where I ask you to identify graph transformations and sketch the final graph of each function, including all key characteristics that I talked about in that video. Okay. So I'm gonna go ahead and move this so that I've got both questions on the screen. Okay. And I'm gonna leave this up here for about 5 minutes, and then we're gonna go over them together. Okay. So whatever notes that you maybe took on this from the video, or whatever other resources you have, I'm going to ask you to go ahead and sketch graphs of these and think about what those graph transformations are that's happening. All, all right. So, folks, before we take a look at these questions, is there anyone who can describe to me what the parent function looks like for what we're dealing with today in the warm up? What's that parent function look like? Yeah, it is 1 over x. And what does that look like visually? Or maybe what are some characteristics that we need to take a look at? So when x is greater than 1, f of x is a downward sloping curve. Yeah. So we kind of have like a branch like that. What else? What other characteristics are there that are important to know about this parent function? From below the x-axis, from the top left, downward sloping, almost touching the y-axis. Yeah, so there's actually one that looks kind of similar on the other side, like diagonally. Okay, so this function in the blue here, this is our newest parent function, okay, 1 over x. But there are some important characteristics about this that I think would be useful to make sure we talk about. Um, what are those characteristics? Like when we talked about exponential functions, we talked about how it had a horizontal asymptote. When we talked about a square root function, we took a look at how it had like a restricted range and a restricted domain. Yeah. So there's a vertical asymptote and there's a horizontal asymptote. Okay. So when we draw these, we really want to make sure we include these in our graph. And I forget what color I used before, but we have a horizontal asymptote. And we could say that the horizontal asymptote is at y equals 0. And then we also have a vertical asymptote that is at x equals 0. Okay. And so when we look at this graph 1 over x, we actually have two different branches and they're separated by the asymptote, okay? And so in the video, I said when we move this function around, whether we slide it to the left or right or move it up and down, we're really thinking about our center point as being the intersection of the asymptotes. Like that's the nice point to move around because then you can sketch the branches around that. Okay. So, that being said, let's take a look at question number 1. So, who can tell me what graph transformations are happening? What happens first to this 1 over x? Yeah, we're going to move it to the right 4. Okay. So, this minus 4 means that you're going to move it to the right 4. And that's the same even though this function looks different from a squared or a squaring or a cubic function, that x and the minus 4 still mean to the right 4. Okay, and so that's going to happen first. And then what happens second here? It's going to go up to, very good. So we've got this up to, and this plus 2 means we go up to, okay? All right, so that tells me where should I draw my vertical asymptote? Where does the vertical asymptote go? All right, so the vertical one is the orange one. Where does that one move to according to these graph transformations? Okay, Richard says it moves to x equals 4. Yeah, I would agree because we're taking the orange. Yeah, this lesson is on the exam. It's all of chapter 3. Okay. So this asymptote is now going to move over 1, 2, 3, 4. And so as you're sketching these, I would actually sketch the asymptote first. We have this to be x equals 4, okay? What about the horizontal asymptote? Where does that one go? Goes to y equals 2, yeah. So I'm just gonna draw that one right there. I hope we can see that. And that one is, oops, y equals 2, okay? And so now that we have our asymptotes, all right, we can go ahead and just sketch in the branches. We know that there's going to be one in the top right, and then another one in this bottom left corner, okay? And that is totally fine for a graph sketch. The thing I'm really looking for is, do you have the right intersection of your asymptotes? And are your branches in the right place? Okay, I'm not particularly picky about how well you draw the branches, but I want to know, do you know where that intersection is, and do you know where the branches are? Okay. Any questions about number 1? All right. So what's the same and what's different about number 2? Okay. What's the first graph transformation that happens here? We're going to move it to the left 1. Very good. So we're at left 1. And we know that because this plus 1 in our equation tells us we're going to move it to the left 1. Okay. All right. Before we talk about the second transformation, this left 1, does that move the vertical asymptote or the horizontal asymptote? It moves the vertical asymptote, exactly. Okay. All right, what happens next after we move this function to the left 1? It's going to have a reflection. And can we be more specific? A reflection over which axis? X-axis or Y-axis? Good, very good, Michelle. So this is a reflection over the x-axis, and we know that because the number in the very front, that is the negative, okay? We can think about that like a negative a value, so that means we're gonna reflect over the x-axis, okay? And the last thing that happens here, we've got this minus 3. And I think we all know that one moves that down 3. And so now we had the left one means we move the vertical asymptote. Okay, so maybe let's write that in. This moves the vertical asymptote. And so that means the down 3, that moves the horizontal asymptote. Okay. And so that means my horizontal asymptote is going to be down 3 units. And we'll say this is at y equals -3. Now, where are my branches going to be? Okay. We can almost think about this in quadrants. Like we've got like a quadrant 1, quadrant 2, quadrant 3, quadrant 4. Where are the branches for number 2? Um, I see what you're saying, Richard. Let's imagine the quadrants are around the new asymptotes. Yeah, then I would say 2 and 4, right? Okay, yeah. I know that's probably not mathematically correct, but let's imagine the quadrants kind of move with that center point of the asymptotes. Okay, yeah. So we've got one branch in 2, and we've got one branch in 4. So let me zoom in for a moment or out. I don't know. So you can see this all on one page here, okay? But this was our warm up for today, just to kind of get those brains moving a little bit. But there are going to be times when I do ask you to take a look at some content outside of class. When I do that, those topics are typically things that connect pretty closely to things that we've already learned. I try not to do too many like brand new things. That you've never ever seen before. I try to make sure it connects to back to something that we have learned. So if that does come out on the announcements, please make sure that you take a look at that in advance. I don't think it ever feels great to start class being like, I have no idea what's going on. Okay. So hopefully this was a good review for those of you who had a chance to take a look at those notes and the videos. But the notes, the blank notes, the complete notes, the video, all are posted on Canvas already. So if you haven't taken a look at that before, maybe you want to take a look at that after, you can certainly speed up the video to do like 1.5 times or 2 times as fast if you want just like a review. But YouTube does allow you to sort of fast forward through things if you need. All right. Are there any questions about this graph and the graph transformations before we move on? All right. Well, these will be at the very end of today's notes that we post if you want to come back and look at them later. But for right now, I'm going to stop sharing my screen. And what we're going to do now is this. So we're actually going to go into 3.7, okay? But what we're going to do is we're going to work on an activity through Desmos, okay? Um, I am going to put you into breakout rooms. You'll still be allowed to request help. So if you and your group kind of get stuck, you can request help and I can pop into the room. I am going to ask, so I'm going to put a link in here first, but I'll put the link after I finish the announcement. So I'm going to send you a link that has directs you to the activity that we're going to take a look at. Now, you can do it together as a group as long as one person shares their screen so that everyone can kind of see it. Does that make sense? Okay. So If you choose to do it where everyone in your group is going to work on the same thing, like one person will type in the answers, but you'll all discuss it as a group. If you choose to do that, when you go to sign in, it says, please put your name here. Just list like the names of everyone in your group there. And if for some reason it doesn't let you do that, then just message me later and tell me these are the people that were in the group. Okay. If you want to, you can also do this individually and put your own name and just kind of work on it on your own. And then together as a group, you can check in. But that's something that I would clarify with your group before you all get started. Okay. So in your breakout rooms, are you going to choose to do it where one person shares their screen and you all kind of work on it together? Or do you want to kind of work on it individually and then ask each other questions as you go? Okay. So think about that before you start the activity. And you should all have the ability to share screens, I think, in the breakout room. So if you can't or something like that, for some reason, let me know. Tell me that you need help, and I'll pop into the room and see if I can help out. We're going to take about 20 minutes to do this. I might, towards the end of that, pop into rooms and just kind of see like how we're doing, if we need more time, if we need less time. Okay. So definitely let me know if it doesn't feel like quite enough time. All right. Are there any other questions right now? Okay. So I'm going to go ahead and put you into breakout rooms. We're going to go a teensy bit smaller today. We're going to have 4 folks in a room on average. Okay. And before we do that, let me go ahead and put the link in the chat, which you should still have access to even if you go to your breakout room.